Hey guys, welcome to iCode. I am Pallav and this is the fifth video of the series Mastering Concurrency in iOS. In the first four videos, we saw concurrency in very detail. From very basics like what is concurrency, parallelism, how it is achieved, OS related concepts like time slicing, context switching, and then everything related to GCD, serial queue, concurrent, synchronous execution versus asynchronous, quality of services, why it was introduced, and then advanced concepts like target queues, attributes, dispatch groups, barriers, semaphores, and everything around GCD in very detail. With all these, we wrapped up GCD in the last video. Today, in fifth part of this series, we will be looking at operations and operation queues. What are they? Why do we need them? GCD versus operation queues and everything else. So let's get started. Before starting with operations and operation queues, let's answer the questions that are popping in your head and not letting you concentrate. Why do we need operations or operation queue or whatever it is when GCD is already there? We saw almost every use case being solved by GCD, then why this new stuff? And if it is there, then where should we use GCD and where should we use operation queues? What's the difference? So if we are trying to compare GCD and operation queues, we are trying to compare apples with oranges. This is because operations are something that are built on top of GCD. They internally use GCD, so how can we compare these two APIs? Just like we cannot compare XMPP protocol with a chat application. Of course, there are cases where we prefer one over another, but that does not qualify them for comparison. So let's see that where should we use GCD and when should we go with operations. And then we will understand operations in very detail. So there's no clear distinction as such, it depends on various parameters, but still, let's try to set some ground rules. GCD is generally preferred where the task is not complex, we are not interested in the state of execution, it's kind of fire and forget. It does not require pause or resume kind of functionality. Basically, less control or less functionality in terms of controlling the task is required. In contrast to this, operations should be used where we are more interested in the state of execution. We want more functionalities for controlling the task. We want to introduce dependencies between different tasks and then we want to encapsulate a block of functionality which can be reused. In such cases, we prefer operations. And some of the developers say that you should always use operations. Why? Because Apple recommends it. Well, Apple recommends a ton of things which we don't adhere to. So let's not use that as an argument here. So Apple says that you should always use the highest level of abstraction available. And because operations are built on top of GCD, they provide higher level of abstraction and hence we should use them. But I feel that most of the times creating operations for trivial tasks is an overkill. Moreover, every time we use an operation, its instance is allocated, on completion it is deallocated. Now assume that I have hundreds of tasks, all of them are very trivial ones, very straightforward, but if I go with the operations approach, this allocation and deallocation will introduce some inefficiency. Of course, it is very optimized, but we cannot neglect that it will be there. Instead, GCD is comparatively faster, easy to implement, so both of them have their own pros and cons, and to understand them in detail, let's dive into operations. Operations is an abstract class. If you are getting confused with the word abstract, let me clear you that yes, you are right. Swift doesn't support abstract classes, but just for the sake of understanding this concept, assume it to be abstract. And because we cannot directly use the abstract classes, they need the implementation in the form of subclasses. So for this, we have two subclasses ready to use, that is NSInvocation Operations and block operations. And apart from these two, we can create our own subclasses. We'll see all these in code, but just try to be with me for a few more minutes so that we get some basic idea about operations. Block operation executes a block, while invocation operation executes an invocation, a method defined by a target or a selector. Similar to adding an observer where we pass a selector, in the same way we initialize invocation operation with the selector and that selector is invoked at the time of execution. But it is important to know that NSInvocation Operation does not exist in Swift. It is only for Objective-C and this can be confirmed through Apple's documentation. So in this documentation, if you see, there's operation, operation queue and block operation. There's no NSInvocation Operation and that is because I have selected the language as Swift. If I change it to Objective-C, you can see that there's NS operation queue, NS block operation and then there's NSInvocation Operation. So this shows that NSInvocation Operation is available for Objective-C, while if you try for Swift, it does not support NSInvocation Operation. So this was something important to know because generally in interviews we say that yes, there's a block operation and there's an invocation operation, and when interviewer asks that if invocation operation exists in Swift, most of the candidates say that yes, because they have never worked on that, but they just read in some Medium article or somewhere that there are two subclasses invocation and the block, and that's why they say it. So it's important to understand this. The way we submit a closure to a dispatch queue, in the exactly same way we can submit an operation to an operation queue. The difference here is that operation is a class, and classes can have properties which can be used for maintaining the states, holding values, etc. What did I just say? Submitting to an operation queue. Now what's that, and why cannot you execute an operation on your own? Of course you can, but the problem is that operations are synchronous in nature by default. So you would never want to execute any synchronous job on main thread. You would always try to getting it off the main thread to some different queue, and that is where operation queue comes. And while we are discussing this concurrency stuff, let me tell you that block operations run concurrently. So you can submit different closures as block operations and they will be executed concurrently on a global queue. If you are finding this a little difficult to understand, I would suggest you to have a look at my previous videos on concurrency where we have been discussing all these things in very detail. That's the base of all these discussions. So if you have directly jumped to this video, you can consider having a look at them once. Now we are almost done with the theory of operations and operation queues, except the state of an operation, which we have been discussing since the start of this video. So what are these states? So an operation can exist in any of the following states, that is ready, when the operation is ready to be started. This happens when the object is instantiated. Next is executing, when the operation is being executed. This happens when start method is invoked. Third is cancelled, when the execution has been cancelled, and this happens when we call the cancel method. And the last one is finished, when execution has finished. The important thing to note here is that once an operation is done executing, we cannot use the same instance for executing it again. One instance can only be used once. Apart from these four states, there are a couple of more useful properties like is asynchronous, is concurrent. So to understand them and to see all these in action, let's jump to Xcode. So whatever we have discussed till now, let's see everything in action, starting with block operations. So let's see that how a block operation can be created, and for that, let's create a method first, which we will be using for executing our operations. So here I created an operation using the block operation subclass. I passed a closure to it, and we are printing the statement, this first test, when this block operation will be executed. After that, I have added a sleep of 3 seconds, and this is to show that the block operations are executed in a synchronous manner. So for that, we are having two print statements in this view_did_load. This one will be printed first, then this block operation will be executed, and if it is a synchronous execution, this should not get printed until this sleep of 3 seconds is completed. So let's try it. Let's give it a run. So we saw that the last statement got printed after a delay of 3 seconds, which shows that the block operations are executed in a synchronous manner by default. We will see that how this behavior can be changed, how can we create custom operations, but one step at a time. We also discussed that we can pass multiple blocks to a block operation, and all of them will be executed concurrently. Let's see that. In this case, we have added 3 execution blocks. Each of them is having a print statement, and once the execution of all the 3 blocks will be completed, it will be treated that the execution of entire block is done. So after that, operation executed will get printed because it is being executed in a synchronous manner, of course. First block executed, third block executed, and this is because all of these blocks are being executed concurrently. So we don't have any surety that which one is being executed first. That is how the concurrent behavior works. We have seen that in way too detail now. So the first block executed, third block executed, second block executed, and finally when the operation was done executing, operation executed got printed because of the synchronous manner. Now because this test operations method is being called from view_did_load, that is from the main thread, let's see that how can we take it off the main thread, but again the nature of the execution will still be synchronous. So we saw that operation executed, this got printed first, and then third, first and second because they were concurrent. And did this run on main thread? That is false because we are using dispatch queue.global, that is we are taking it off the main thread. But again, the nature of execution of a block operation is still synchronous. It's just that we have taken it off the main thread. Now let's say that we want to get a callback once the execution of an operation is done. So that can be done using the completion block. For that, so we see that second, third, first, then we got execution completed, and after that we got this print statement that did this run on main thread. So using completion block, we can get a callback whenever the execution of an operation is completed. So for the trivial task where you don't need much customization, you can directly use block operation. It is a concrete implementation of the abstract class operation. But what if you want to create your own custom class, your own operation? We'll see the proper implementation with the use case in some time, but let's just take a glimpse of it. So how can we create a custom operation of our own? So here we created a class custom operation, subclassed it from the class operation, the abstract class, of course. Then we provided the custom implementation to the main method. So if we go in this operation class, we see that there's a main method. So in the execution cycle of any operation, first start is called and then main is called. So we provided a custom implementation for the main method. We printed the numbers from 0 to 10 here. And from here our view did load. We are again calling the start method, which started the execution of the operation. But again, this is happening on the main thread. And what if we want to take it off the main thread using the start method? How can we do that? So for that, let's override the start method as well. So what we did is that we override the start method. We created a thread inside the start method, and then we passed this main block to this thread. So thread can be initialized by passing a block. In this case, we pass our main to this thread, and then we called the start method of the thread. So this way we took the execution of this custom operation of the main thread. We see that custom operation executed got printed first, and then our numbers got printed. But is this the right way? Of course not. In all our previous videos, we have seen this in very detail that we should not directly deal with the thread class. There are tons of other APIs available for handling the concurrency, but we should not deal with the thread class directly. It is very raw at the root level. We'll have to manage the memory allocation, deallocation, and a ton of things on our own. So it's not recommended. And if it is not recommended, if we should not use the thread class here, then what should we use for taking it off the main thread? And there comes operation queue. So we didn't do much here. We created an operation queue, a block operation, provided an execution block to our block operation, a completion block, and then added that operation to the operation queue. This print statement is still here and it is for a reason. Let's give it a run and let's see that. We see that custom operation executed, it got printed first, then operation 1 being executed, and then one operation executed. So this proves that this operation is being executed on a different thread. It is not on the main thread, and moreover, the problem that we were facing because of the nature of the execution of block operation, that is synchronous, that till the time the execution won't complete, this statement was not getting printed. That has been handled by operation queue, because operation queue executes the operation on a different thread. So that is really cool. But can we add more operations to this queue? Yes, of course. So I just copy pasted this entire block, the creation of an operation, a block operation, a completion block, and an execution block, and added two operations to this operation queue. And let's see them. One being executed, two being executed, one executed, two executed. So it just works flawlessly. And now to see the proof of these operations being executed concurrently, let's make some changes. We see that 0, 1, 2, 3, and then 11, 12, 13. So this proves that both the operations are being executed concurrently. But can we make them serial? Is there any way possible? And that we can do using a property that is maximum concurrent operations count. Let's try that. On this operation queue, max concurrent operation count, let's set it to 1. Now this will decide that at a given point of time, the maximum concurrent operations that can be executed on this queue is 1. We can change this, of course, but because we want to try the serial behavior on this, I have set it to 1. And now we see that first 0 to 10 got printed, the execution of 1 was done, and then 11 to 20 got printed, and then the execution of second was also done. So this is how we can change the number of maximum concurrent operations being executed at a given time. And now let's see that how can we add dependencies between these operations. Because when we talk about the benefits of operations over GCD, dependency is one of the things that is always discussed, that is always brought into the discussions, that operations can have dependencies. So let's see that how can we have them. As simple as that. I have just called this method add dependencies on operation 2 and passed operation 1 as the parameter, which says that the operation 2 should wait till the time operation 1 is done executing. Basically, operation 2 is having a dependency on operation 1. So in this case, if the operation 1 will get executed first, we'll get the output as 0 to 10, and once that dependency will be resolved, that is, the execution will be completed, operation 2 will start get executing. So then we'll see 11 to 20. Let's see that. And let me remind you that I have removed the line of setting the number of maximum concurrent operations. So we see here 0 to 10, 11 to 20, and then the completion blocks of both of them. Now here's a little catch. The completion blocks might not get executed at the expected time, at the predicted time. There can be a slight delay in the execution of the completion blocks, but this is guaranteed that the operation 2 will start get executing only when the operation 1 is done executing. So if I try running this couple of times, maybe we can see that. You see, operation 1 executed, it got printed after 16 was printed. So this clearly tells us that the completion block was executed with a slight delay. This may not be the case always, but yeah, we should consider this if we are relying on the completion block, and if we are trying to execute something critical in the completion block, that it can execute with a slight delay, and the second operation, which was dependent on the first one, it can start its execution before the completion is even called. Now let's see something interesting. What if I try performing an asynchronous job in an operation and then try to use the dependencies? How will it work? Let's see. So here I have created two operations. Operation 2 is having a dependency on operation 1, and both the operations, that is the block passed to these operations, both of them are having an asynchronous job. Now let's see that how this works. We see that custom operation executed, this print statement got executed because of course operation Q took it off the main thread, so this got printed. But about the two operations for which we added the dependencies, the dependency didn't work. We can see that the numbers are printed in a random order, 11, 12, 0, 1, 2. That is, the numbers are printed from both of these operations, and this shows that this was executed in a concurrent way. But why this line didn't work? We added a dependency on operation 1 that till the time this is not done executing, operation 2 should not start its execution. And the reason is that for asynchronous jobs, the operation is assumed to be completed as soon as this block will finish its execution. In the meanwhile, if you have executed something asynchronously, if you have created some other thread, or maybe if you have added some job to some other queue, it won't be considered, and this block will be considered that this is done executing, and hence this dependency will be resolved. As soon as this dependency will be resolved, operation 2 will start its execution. So how can we deal with this problem? Because of course, if we are using operation queues, if we are using operations, we are somewhere dealing with some asynchronous jobs. Maybe you want to download an image, or you want to make an API call, and that is why you are using operations. You have wrapped that code in an operation that is an asynchronous job, of course. But if this is the case, then it doesn't solve any problem. So how can we deal with this? And for that, we can use the states about which we learned. The is ready, is executing, is finished, is cancelled. Those properties which are controlling the state of an operation, through which you get to know that whether it is completed or not. We can use those properties here. Let's see them. So I'm having a saved code snippet for a async operation class, It is a subclass of the operation, but it deals with this problem. So let's just try understanding this. I'll walk you through the code. The code will be available on the Git as always, so you can fork it from there. I'll put the link in the description. Let's just go through the code. Let's see that what is happening here, and then we'll try to use this async operation class to deal with the problem that we just encountered. So in this class, we created an enum that is a state, and this state is having is ready, is executed, and is finished. That is exactly same to what operation class uses, but because those are the get only properties, we cannot set them. That is why we have created something similar to that. And just to show you once, if you see is executing, is finished, is ready, all of them are get only properties. So to achieve something on those lines, we created an enum state. We will be using state over here. We have assigned is ready as the initial, as the default value, and then we are using this will change value, did change value, and that is because operation class relies heavily on the KVO, that is key value observing. So I'm assuming that you guys are familiar with the KVO concept, that how can we use KVO for observing the change in the values, the key paths and all those. And if you are not, just put it in the comments. I'll try to cover KVO in one of my videos. So here we are using this will change value and did change value. These are the methods written in the NS key value coding. If you see them, that declaration is in this class, that is the extension of NS object, and that is foundation.ns key value observing. So we are using these methods for informing that the state has changed, and then we are using the new value and the old value that we get through the will set and the did set block. That way we are changing the state property, and then we are overriding these three properties, that is asynchronous, is executing, and is finished. Is asynchronous, of course we want it to be true. That is the reason that we are writing this custom implementation. Is executing will depend on our state property. Is finished will also depend on our state property, but here we are having the handling for the cancelled case also. So if the cancel method will be called for the operation, the state will first change to is cancelled and then to is finished. So we are using is cancelled property here for setting the is finished property in the block where we are overriding it, and then the start method and the cancel method. So in the cancel method, there's nothing much to explain. We are just setting the state property to is finished. In the start method, we are first checking that if the operation has not been cancelled. If not, we'll execute the main block, otherwise we'll just return it from here. So there's a guard for it, that's it. Now we can use this implementation, async operation, this custom implementation in which we are handling the is asynchronous, and specifically the states through which it is determined that an operation is still executing or it is done, on which the dependencies rely. So that should be sorted now. So now let's try using this async operation for what we were trying to achieve. So here we have created another class, that is print numbers operation, and we have subclassed it from async operation. Now in this print numbers operation, we have taken range as a parameter that will be printing, and then we overrode the main method in which we are executing an asynchronous job, that is through dispatch queue.global.async. And once that will be done, we have changed the state to is finished. Now let's use this here. So instead of block operations, we are using our print numbers operation, and now let's see that the dependencies work or not. We see that custom operation executed, that was expected, then the numbers got printed from 0 to 25 and then from 26 to 50. So that was the expectation, that even if the operation is asynchronous, the dependencies should work. And that was possible because we managed the state of the executing operation using the custom implementation. So that's pretty much about the operation and operation queues. Now the state property that we have taken in our custom implementation, it should be thread safe, and we can add handling for that. Now we have learned it, that how to use dispatch barriers, semaphores, how to deal with the critical section. So let's not go into those details, but yeah, this is how we can create our custom operations. We can use them for these scenarios. And if you want to see that how can we make something thread safe without adding those handlings, actors is something that has been added in Swift for dealing with the concurrency related issues without providing the custom handling. So if you want to learn about the actors, here's the link to one of my videos which I did on actors. You can have a look at that. So this brings us to the last video of this series, that is mastering concurrency in iOS. I have already covered actors, async await, and the latest introduced in the concurrency in my other videos. So you can have a look at them. And if you want me to cover them again in detail, you can mention them in the comments. I'm yet to do a bonus video of this series that was interview questions on concurrency, and that will be available very soon. If you like the channel and videos, you can consider subscribing to the channel. Let's write better code together. Happy coding, stay safe.